Hello again, everybody. This is our video solution to problem 3 from Superquiz 3. In this problem, we're going to be computing the TNB frame for a curve, which is given by the following parameterization. It's not told exactly here, so we can assume then maybe it's working for all t. But we actually only want the TNB frame when t is equal to 1. So recall the TNB frame, right? The TNB stands for the tangent, normal, and binormal, and these are all assumed to be unit vectors. In particular, well, once you know the tangent and the normal are the unit tangent and the unit normal, the binormal will have to be a unit because we'll get it by taking the cross product of t and n. So the first thing we need to do is compute this t. So we're aiming for our t hat here. And of course, t hat is just going to be given by taking the tangent vector and dividing it by the magnitude of the tangent vector. Cool. Finding magnitudes is pretty straightforward, so let's just try to find t itself. So we can compute the tangent vector by computing the derivative of r prime. That's just that simple. So we're going to be looking for the derivative of r prime, of r. All right, and let's see. So the derivative of r, we just do it term by term, and we get 2, 0, and 2t. Cool. So our unit normal, or rather unit tangent, is going to be 2, 0, 2t divided by, well, we want the magnitude of 2, 0, 2t. Okay, let's see. We can copy the numerator. And what's the denominator? Well, this will be the square root of, we have to take the sum of the squares of the components. So 2 squared is 4, 0 squared is 0, and 2t quantity squared will be 4t squared. And I guess if I like, I could factor a 4 out of this. When I pull it out of the square root, it will become a 2. So I could rewrite this as, well, and I'll just put the 2 up on the top as a 1/2. 1/2 2, 0, 2t divided by the square root of 1 plus t squared. And I put this 2 up here on the top as a 1/2 because I can see it's going to cancel some of these 2's. So I end up with 1, 0, t over the square root of 1 plus t squared. All right, so each one of these components will ultimately have to be divided by this. I'm just leaving it out for the moment because at the end of the day, I'm going to want the TNB frame when little t is equal to 1. So if I want t hat at 1, I can just substitute 1 in for t at this point. And so I'm going to end up, let's see, on the bottom, t equals 1, I'll get 1 plus 1 is 2, so just by the square root of 2. So this will be 1 over the square root of 2, 0, and then 1 over the square root of 2 times t. Oh, well, t, what's t? T is 1. We don't have to, we can just put t equals 1 in there. Okay, so we found the t of our TNB frame. Next, we want to compute the n. And we get the n, let's see, we want n hat, and of course n hat is just going to be, oops, regular old n divided by its magnitude. Fine, so we need to know regular old n. Well, regular old n is given as the derivative of the unit tangent. So I take my t hat, and I'm going to take the derivative with respect to t. Okay, so what that means, maybe I'll go up here and include all this nonsense. Well, okay, I actually don't want to write it in the same way. So dividing by the square root of something, same as multiplying by 1, by that something to the negative 1/2. So this will be 1 plus t squared to the negative 1/2, comma 0, comma t times 1 plus t squared to the negative 1/2. Okay, so I need to compute the derivative of this, and it'll happen term by term. So let's see now. Let's see. What I can do is take the derivative, and that's, I mean, it's just, it's annoying, but it is. So for the first term, we're going to get negative 1/2 1 plus t squared to the negative 3 halves times the derivative of 1 plus t squared, so times a 2t. Hey, the middle term, that's not too bad. That's a 0. Okay, this last one looks like a product rule coming. So let's see. If I first differentiate the t, that's going to be pretty easy. I'll just get 1 plus t squared to the negative 1/2 plus, now I keep the t fixed, and I take the derivative. That'll be the same thing as I had in the first term. So in fact, I'll just insert this t in there. Notice the 1/2 and the 2 will cancel, so we get negative t squared, 1 plus t squared to the negative 3/2 power. All right, now at this point, I sort of want to cry because I don't want to compute the magnitude of this thing that just looks like it's going to be a pain. But I actually don't need to compute it first. In fact, I could have done this with the t, but everything was so easy I didn't feel the need to do it. But we could have done it. We could have done this. So let's say I'd just stopped at t itself, and I'd computed t of 1. Well, t of 1 is going to be 2, 0, 2. So what I could do then is when I wanted to compute t hat of 1, I could have said, well, this is t of 1 divided by the magnitude of t of 1. Well, this would end up being 2, 0, 2 divided by the magnitude of 2, 0, 2. Okay, what is the magnitude of 2, 0, 2? Well, let's see. This is going to be the square root of 4 plus 4, which is 8. Okay, so this is equal to the square root of 8, or if you like, 2 times the square root of 2. Okay, so then we could have divided all this by 2 times the square root of 2. And so that would have left us with the vector. We'll see, 2 over 2 root 2 will be 1 over root 2. 0 over it will be 0. And then again, 1 over the square root of 2. Same answer as we had up above. So before you compute the magnitude with all the variables still in, if you're looking for the TNB frame at a specific t, you can evaluate your non-unitized version and then divide by the magnitude at that particular point. So we're going to do that here with n. So I'm going to compute regular n of 1. All right, now let's see. My regular n of 1, okay, the half and the 2, those canceled. The t is now 1, so that's just going to go away. 1 plus 1 is 2. And then I'll raise 2 to the negative 3 halves. So what does that mean? Well, there's a negative out front. And then I'll have 1 over 2 to the 3 halves power. Okay, it's the square root of 2 cubed. Okay, actually, if I cube 2, I get 8. So this is really the cube root of 8. Or, I'm sorry, the square root of 8. But square root of 8, that's 2 root 2, right? We already saw that. So I just get negative 1 over 2 root 2. Second component, hey, that's already a 0. Third component, all right, if I make t equal to 1, I get a 2 to the negative 1/2 power. So that will just be 1 over the square root of 2. Plus, but then there's a minus. Minus, okay, t squared, well, it's just 1 squared. And again, okay, this is 1 plus 1 is 2. Hey, it's the exact same thing. So this is 1 over 2 root 2. Okay, and I think we could probably simplify this piece here. It's just half of that, so we should just end up with exactly this amount. So this should be 1 over 2 root 2. Sweet. So our n of 1 is negative 1 over 2 root 2, comma 0, comma 1 over 2 root 2. And so to compute n hat of 1, we're just going to have to take this and divide by its magnitude. Okay, fine. So negative 1 over 2 root 2, comma 0, comma 1 over 2 root 2, divided by the magnitude, which I'm just going to write more simply here. And let's just do the magnitude calculation on the side. Let's see, if we square this, the negative goes away, and we get 1 over 4 times 2, that's 1 over 8. So the magnitude is going to be 1 over 8, and then 0, and then another 1 over 8. So that's 2 over 8, which is 1 over 4. And then we take the square root. That's square root of a fourth is a half. So this down here is actually equal to a half. Dividing by a half is like multiplying by 2. And so our n hat of 1, we just multiply these all by 2, and we get negative 1 over root 2, 0, and 1 over root 2. Cool. So it looks very similar to the t-hat we had. Okay, what's left? Well, the last thing we need is our binormal at 1. And we can get the binormal by simply taking the cross product of the two tangent vectors. The tangent vector and the normal vector. So we're going to take the cross product of 1 over root 2, 0, 1 over root 2, cross product with negative 1 over root 2, 0, and 1 over root 2. Right? Or as I prefer to write it, we'll just do it on the side. 1 over root 2, 0, 1 over root 2 times negative 1 over root 2, 0, 1 over root 2. And let's see, when we do the cross product, hold the first things constant, or just ignore them. 0 minus 0, okay, that's 0. Okay, now to get the second component, okay, we'll go backwards. So 1 over root 2 times negative 1 over root 2, that'll be negative a half. Then the other way, minus a half, so negative a half minus a half, which will be negative 1. And then we cross off the third column and we do 0 minus 0, which is 0. Okay, and so our cross product is going to be 0, negative 1, 0, or some of you may know this as negative j. So our binormal is going to be a unit vector pointing in the opposite of the positive y-axis, or the negative y-axis. Okay, and that's how we can get our TNB frame. This problem becomes a lot harder if you don't introduce the 1, right? If we had just said compute the TNB frame in general, then, I mean, it's not technically harder, but it's like for humans harder, right? Because now you have to start doing all these calculations with just the t's in place. And eventually you're going to have to do this cross product, and there are going to be these very messy formulas. But when we specialize at t equals 1, we can make use of some of these simplifications along the way, and that'll help us out in the long run.